Exercise 7, coordinate geometry, parallel and perpendicular lines. Find the equation of the straight line through the origin perpendicular to the line with the equation x plus 2y minus 4 equals 0. Hence find the coordinates of the point of intersection of the two lines. Now pause the video and I'll give the answer or the answers and then the solution. Okay, well the answers are, the equation of the line is y equals 2x and the point was 4/5, 8/5. Okay, now here's the solution. Now we have this one here, x plus 2y minus 4 equals 0. Rearranging that, we'll have 2y equals minus x plus 4. So y equals minus a half x plus 2. Now, we can see that the gradient here is equal to minus a half. So the gradient of the new line will be, m1 is that, m2 equals 2. And since it passes through the origin, the equation will be y equals just 2x. Now, solving those two simultaneously, we have, of course the y's are both the same, we have 2x equals minus a half x plus 2. Adding half x to both sides, we get 5 on 2x is equal to 2. And multiplying both sides by 2 and dividing by 5 at the same time, we get x equals 4 on 5. And of course, y is twice this, so y equals 8 on 5, which is the required result, what we had before. In number 2, we've proved that the points A, 1, 3, B, 3, 7, C, 0, 14, and D, minus 2, 10 are the vertices of a parallelogram. And this time I'll need to plot these points on the number plane, approximately. And we'll just plot the point 1, 3, make that 1, 3 is there, that's A. Then the point B, 3, 7, 1, 3, 4, 5, 6, 7, it's about there. C is 0, 14, oh, we're up here somewhere, or out there somewhere. And we've got the other point D, which is minus 2, 10. Minus 2, 10. Well, didn't do this too good, did I? Okay. Oh, minus 2, 10 would be up here somewhere, wouldn't it? Okay. D. That just gives you an idea of what size we got to consider. So clearly we've got to try and prove that one is parallel to that one, and that one is parallel to that one. So let's look at the gradients. First of all, look at the gradient of AB. The gradient of AB is going to be different in the y value, so it's going to be 7 minus 3 over 3 minus 1, which just gives me 2. The gradient of CD, this one here, is going to be 14 minus 10 over 0 minus negative 2, and again that's going to give me 2. So we can say that AB is parallel to CD. And looking at the other ones, we see the gradient of BC is going to be 14 take away 7 over 0 take away 3, which is 7 on negative 3, or minus 7/3. And the gradient of AD is 3 take away 10 over 1 take away negative 2, which again is minus 7 over 3. Therefore, BC is parallel to AD. Okay, now since that's pair are parallel and those pair are parallel, therefore we can say A, B, C, D is a parallelogram. Two pairs of opposite sides are parallel. A straight line, number 3, a straight line is drawn from the origin O, perpendicular to the straight line 4x minus 3y plus 12 equals 0. To meet the line at P, calculate the length of OP. Now, this particular type, you really need to draw a diagram. What I'll do, I'm going to write this equation in the intercept form of a line. So what we're going to do here is we write that down as 4x minus 3y equals minus 12. And I'll divide through by minus 12. And here I get x on negative 3. This will be plus y on 4 is equal to 1. Okay, so the intercepts are 4 and minus 3. Minus 3 there, 1, 2, 3, 4 up here. So there goes our line. And through here like this. Okay, so there's our line. Now you can see the straight line is drawn from the origin O, perpendicular to this line, like such. To meet the line at P, we have to find the length of OP. Now if we work out, this is the point, where are we? This is 3, and this is 4. Now you can see here that if we work out the area of that triangle, the area of the triangle is half the base times the height, which is going to be 6 units squared. Now then if we work out this distance here, okay, we'll call that AB or something. So AB, you can see from both axes that's a 3, 4, 5 triangle. That's AB is 5 units. Now this is the height. OP is actually the height of this triangle. So the area of the triangle is equal to half the base, which is 5, times the height. So here we can see that 12 equals 5h. So h equals 12 over 5, or 2.4 units. Is the perpendicular, or the length of OP is 2.4 units. Exercise 7, coordinate geometry, parallel and perpendicular lines. Number 4. 3 points have the coordinates A, 3, 6, B, 2, 0, and C, 4, 8. The point D is the foot of the perpendicular from A to BC. Calculate the coordinates of D. Okay, now just pause the video and have a go at that. I'll give you the answers, then the solutions. Okay, the coordinates of D are a bit messy. They were actually fractional ones. So D had the coordinates 3 and 8 seventeenths and 5 and 15 seventeenths. Right, normally in the exam they would come out to whole numbers, but let's see how we go with this one. Alright, so let's plot these points first. So we'll have the point 3, 6, 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7, 8, 3, 6 about there. That's A. And the point 2, 0. We have point B is 2, 0. And the point C, which is 4, 8 there. That's the point C, which is 4, 8. So we'll join BC, E to C. And the point D is the foot of the perpendicular drawn from A to BC. So that's the point we're after. First of all, I'll work out the the gradient of BC. So the gradient of BC, difference in the what these points are might be easy to see. That's 2 naught. That's the point there, which is 3, 6. Okay. So BC has the gradient of 8 take away 0 over 4 take away 2, which is a gradient of 4. So the equation of BC is y minus 0 equals 4 outside of x minus 2. So y equals 4x minus 8, and we'll call that equation 1. Now we'll look at the equation of AD. Now because it's perpendicular to BC, it will have a gradient of minus 1/4. So that will be y minus 6, taking this one, equals minus 1/4 outside of x minus 3. And we'll make y the subject, so that's equal to minus 1/4 x plus 3/4. So y equals minus 1/4 x plus 6 3/4. We'll call it equation 2. Because y's are both the same as this one, different colour here. So we've got this one here, this one here, and we've got this one over here. So I'm going to just equate those two, solving simultaneously, and we get 4x minus 8 equals minus 1/4 x plus 6 3/4. So we get 4 1/4 x is equal to, taking the 8 across the other side, 14 3/4. So x equals 14 3/4 divided by 4 1/4, which comes out on the calculator as 3 8/17. Substitute that back into this one here, number 1. We get 4 times 3 8/17 minus 8, and that gives the result of 5 15/17, and that's what we got before. Okay, this is the last one, number 5, rather a bit more challenging, but a rather nice result. Now write down the equation of the straight line through 0, 1, perpendicular to the straight line y equals m outside of x minus 1, and find in terms of m the coordinates of P, the point of intersection. Okay, so then we'll pause the video and I'll give you the answer. Okay, now the answer, excuse that cockatoo screeching in the background, can't do much about him. Okay, now we have y equals minus 1 on m, x plus 1 is the line, and the point of intersection is m outside of m plus 1 over m squared plus 1 and m outside of m minus 1 outside of m squared plus 1. Quite a nice bit of symmetry there, isn't it? He's a bit of a noisy old fellow, isn't he? Alright, okay, now what we'll do here for the solution, we've got this one, we've got y equals mx minus m for this one. So the gradient is m, m1 equals m, and m2 equals minus 1 on m. So quite simply, y equals minus 1 on mx plus the y-intercept of 1. which we had up there. What we have to do here, we have to solve these two simultaneously. So we've got this one here, 1, this one here, 2. So like the previous example, we'll just solve those. So we'll have mx minus m is equal to minus 1 on mx plus 1. So now we'll take that across the other side. So we have mx plus 1 on mx is equal to m plus 1. Take that across the other way. So that becomes m plus 1 on m x equals m plus 1. And this of course becomes m squared plus 1 over m x equals m plus 1, which of course gives the result x is equal to m coming up here, m outside of m plus 1 over m squared plus 1, and that's what we had up here. Now, substituting that back into this equation here, we'll have y equals m, that'll be m squared, m plus 1 over m squared plus 1 minus m. Okay, and that becomes m squared outside of m plus 1 minus m outside of m squared plus 1 all over m squared plus 1, and that becomes m cubed plus m squared minus m cubed minus m over m squared plus 1. These guys go out, and we get the m out, take m out as a common factor, and we get m minus 1 over m squared plus 1. Quite a nice symmetrical thing, isn't it, to look at?